Welcome to the Exponent Laws, Day 3. So we're going to learn a couple more laws today. So far we've covered multiplying exponents, dividing exponents, and then when we have a couple exponents, power over power in the air, how do we clean them up and simplify them? Okay, so today we're going to learn a couple more. So we're just doing an investigation to kind of analyze one of them. So I want you to take the first one and just go 3 divided by 3. What should you get? Okay, and a lot of people get this wrong, so double check with your calculator too. Okay, so I'm just here. I have a calculator here as well that you guys can look at. So I'm just going to go 3 divided by 3, and I get 1. Okay, a lot of people end up writing 0, so that's why I just want you to be careful. If you take the same number divided by that same number again, you get 1. So let's write that in. Okay, so you get 1. All right, so now let's try the next one, but we're going to use exponent laws. Okay, so you've learned that if you have an exponent divided by another exponent, you can use the exponent law where you subtract the exponents. So what you're going to do here is you write the base and then you subtract the exponents. So when you do that, 1 minus 1 is 0. Okay, so like what you did back here with the one on the first question here, it's like 3 to the 1 and divided by 3 to the 1. Okay, so when you did that, you got 1. Your answer was 1 when you took your calculator to it. So really, in the end, you used exponent law here, and you went 3 to the 1 minus 1 like that, and you get 3 to the 0, and your answer to this is 1. So if you get an exponent of 0, so you can even try it on your calculator here. So you're going to go 2, and then the exponent button on this calculator is this roof button here. Okay, 0 equals 1. Okay, so on your calculator, the exponent button is, so it could look like this, x to the y, like that. Some of you might have a y to the x. Some of you might have the roof. Okay, I don't know what other letters that might have, but anyway, so if you see one of those, even if it's your phone, they will have buttons like that. So if you go, in this case here, it would have been 2, and then you hit your exponent button. So in the calculator I use this roof button, 0, and then equals, and then I got 1. Okay. All right, so try the next one. Again, do it from the standpoint of exponent laws. So I don't want you to go 4 to the 5 and calculate a big number out. I just want you to go, okay, so if I'm dividing these, that means I can subtract the exponents. So I get 4 to the 0, and we figured out that when you have an exponent of 0, you get an answer of 1. Okay, so same with this one here. There is an exponent 1 there that you don't see. So it's negative 5 in brackets, and it's 1 minus 1. So you get negative 5 to the 0, which is 1. Okay, so if you have, so the conclusion here is if you have an exponent 0, the answer is 1. Okay, so whenever you have the exponent 0, you get an answer to 1. Okay, so again, this is important that you pay attention to where the exponent is attached. So if it's attached to this number here, then you're going to write that will equal 1. But when it's not near the some other numbers, don't just assume everybody is equal to 1. Okay, so just be careful. You're always following BEDMAS. Okay, so we'll kind of look at a bunch of examples here, and then you should get more confident with these. All right, so now that we know the 0 exponent rule, so any non-zero base, so basically the base, the number at the bottom, if its raised has an exponent of 0, then it's equal to 1. Okay, so here's a general rule, x to the 0, so it doesn't matter what x is. If it has an exponent 0, it'll equal 1. Okay, but just one condition is that you can't have x equal to 0. All right, so let's go through these ones and calculate the answers. Okay, so again, if you when in doubt, you you can't remember how to, like, what the rule was, you can take your calculator. So we have 358. All right, so if I move this over here, so we have 358, okay, to the exponent 0, okay, hit it and you get 1. Okay, so that's something that you can try to do whenever, like if you can't remember the rule and so forth on an assessment. Okay, so this is equal to 1. All right, x to the 0, okay, regardless of what x is, as long as it's not 0, it's equal to 1 as well. Okay, so go ahead and work ahead of me. So there we go. All right, here is this really big number to the 0 exponent, 1. Okay, and then now it's getting a little more complex here. So we have a bracket, okay? So BEDMAS says, you know, do something in the bracket first, okay? So there's nothing you can do in here. So then you're going to move to the exponent. So since this exponent 0 is outside of the brackets, everybody inside belongs to this exponent 0. So that means regardless of what is in this bracket here, because this exponent is outside, it's equal to 1. Okay, so the whole thing just changes to 1. All right. And then we'll go through kind of combining what we did the other day. So I have an exponent divided by another exponent. They have the same base of 3. So that means I'm allowed to do my division rule, which is subtracting the exponents. So when I do that, I'll get 3 to the 0. And again, if you have a 0 exponent, your answer is 1. All right, here's another one where you have some numbers, doesn't matter what it is, inside the brackets. Exponent 0 is on the outside, so 1. And then, all right, and then be careful with the next one here. It looks kind of like the one in F, but, so remember what I said, it's wherever the exponent is, that's where, that's what the exponent belongs to, okay? So on here, the x here has an exponent 0, but then the 5 doesn't. So you have to follow BEDMAS here. So if you do that, you're going to find that, so you don't have any brackets, that's fine, but you have to do the exponent first. So if you do that, that means this part here, okay, that's what belongs to the exponent 0. Okay, so think of it as like that. 0 exponent owns the x. So you're going to do that first before you do multiplying, okay? So you're going to do the exponent first before you multiply to find your answer. So in this case here, so you're going to get 5, okay? But then it's being multiplied to this x to the 0, which is, the answer is 1. So your final answer here is 5. Okay, so just be careful with that one there. When you don't have brackets, the exponent 0 only belongs to the base that it's touching, I guess. Where if you do have brackets, it's saying all of this stuff belongs to this exponent. Where here, just the x belonged to the x 0 exponent, so it became 1, and then the 5 just came in later and multiplied with the 1. Okay, so those are several examples of 0 exponents. We'll do some more in a bit. I just want to teach you the other rule, which is negative exponent. Okay, so with the negative exponents, so with the 0, you know it equals 1, but with the negative ones, just think we can't have a negative. Okay, we have to change it so that it becomes a positive exponent. So in order to do that, there's this little trick that you can do, and we've done it before with other, like the trig questions and so forth. So in order to fix this, all we're going to do is flip fraction, okay? So if we have, like if I have x to the negative a right now, so I don't like that there's a negative exponent, we have to change it. So all you're going to do is draw 1 underneath, okay? And then to fix this, you flip it. Okay, so when you flip it, okay, the exponent, negative exponent a becomes a positive exponent, and now we have a positive exponent, and that's what we want. Okay, so let's go through and fix these, all right? So here we go, we have 2 to the negative 3. So again, we know there's a 1 underneath. So in order to get this to a positive exponent, we're going to flip it and write it like that. Okay, so the 2 goes to the bottom, 1 goes to the top, but then see the exponent, it changes to a positive. All right, and then last day we just kind of left our answers like this. Today I want you to take an extra step and actually go through and calculate it. So then from there, 1, and if you're trying to figure out what 2 to the 3 is, so let's do that on our calculator, practice our exponent button. So we're going to go 2 to the exponent 3 equals. Okay, and that makes 8. So that makes sense. 2 times 2 times 2 is 8. So that's the new thing today. I want you to learn zero exponents, negative exponents, but I also want you to go through and calculate out the number today instead of leaving it as an exponent, if you're able to, okay? All right, here's the next one. Again, negative, don't like that, so just to remind yourself there is a 1 underneath, flip it. Okay, so it's like you gotta get it to a positive exponent before you can calculate with it. All right, so now from there, we have 5 squared. So again, you should know what 5 times 5 is. If not, no worries. 5 exponent 2 is 25. Okay, so you've seen 2 examples here where you just had to change it. So even if, yeah, you just change it to a positive before you calculate. Here, I'm going to add one more example here. What if it already looks like this and you have, say, like 3 to the negative 2? So it's already a fraction. The negative exponent's at the bottom. How do we fix this? Well, just like I taught you up here, just flip it, okay? So when you flip it, the 3 to the 2 goes up here, and the 1 goes down here. But on top of it, see how the negative 2 became a positive 2? So that's what you want to see. So you get 9 over 1 equals 9, okay? All right, so yeah, so if it's just with, not looking like a fraction, just flip it. If it looks like a fraction, flip it. All right, so here's C now. It looks a little bit more complex, but same thing. I know it's a fraction, but how do we fix this negative? We flip things. So all you have to do is flip the fraction inside the brackets like that. And when you do that, I know like normally the exponent went with wherever it was with, but here the exponent's sitting on the outside. So it's a little trick here. You just flip the fraction inside, and then it becomes a positive 4, like that. Okay, and then from there, this is kind of like what we did last day. You should know that those ones on the inside have an exponent of 1. Okay, when you don't see an exponent, it's an exponent of 1. So what are you allowed to do when these 2 exponents are up in the air like this? You're allowed to multiply them. So we're just going to write that one. Oops. Here. So we're going to have 2, okay, has an exponent 1 like that. So we're going to times it by 4. Okay, and we want to be fair here. So this 4 multiplied in with the exponent 1 here, but we also have to multiply it into the 1 at the bottom. Okay, so this exponent, or 3 has an exponent 1, but we need to multiply it by 4. Okay, so then you clean it up. You get 2 to the 4 and 3 to the 4, and then you can just calculate those out. Okay, so we need a bit more space for that. Let's see if we can squeeze it in. So 2 to the 4, if you use your calculator, is 16, and 3 to the 4 is 81. Okay, and I'm okay if you leave it like that. If you want to change it to a decimal, you can as well. All right, let's go to the next one here. All right, so, and see, we had numbers. Here we don't, but that's okay. We just have to fix the negative sign, okay? And then we're good to go. So, again, how do we fix it? We flip things, okay? If we flip the fraction in here, when we do that, they both get a 5. And then if you want to multiply that 5 in, okay, so remind yourself, even if it's just the letter X or Y, they do have an exponent 1 that we don't write in. And then we'll multiply that 5 in now. So it'll become Y is 1 times 5, and X is 1 times 5. And then you go, whoops, then you go Y to the 5, X to the 5. Okay, so that's kind of, you want to go as far as you can, kind of working into the brackets, and then write your final answer like that. All right, so those are the trickiest ones, but let's see what you can do. So I'm going to start off with some examples here at the bottom where there are zero exponents and negative exponents, and then get to ones where they're combined. Okay, so let's move on to these ones now that we've seen. Okay, so again, let's just recap here. Zero exponents, so again, if you have an exponent attached to you that's 0, your answer, you just wipe out and turn it into a 1, okay? And with negatives, we don't like negatives. We need to change it to a positive before we can do anything with it. So the trick is to flip whatever you have. So if it's just the number, write a 1 underneath, flip it. If it already is a fraction, flip it. And again, if there's another fraction here with a negative exponent outside, flip it, and then just multiply that new positive exponent into both of them. All right, so let's go through here and try these examples out. Okay, so the first one here is 5 to the 0. So again, the 0 is attached to the 5. There's nothing else here, so this turns to a 1. Okay, same with 3. So it doesn't matter if it's a different base, still applies, becomes 1. Here, we don't even know what the base is. It could be any sort of number that can go in for x, but we know that regardless of what goes in there, it becomes a 1. Okay, and then if it gets a little bit messier here, but in the end, see how it's a bracket, and then this the 0 is sitting outside. That means the 0, you can think, is owning everybody in here. So that makes it 1 as well. All right, and even if it looks slightly different, so you're still always trying to apply all the different rules that you've learned. So you know if you divide exponents, okay, you know you have to subtract them, the exponents, and you get 0, which is equal to 1. Or some of you may have looked at this right here and go, oh, these would just cancel out. So when they cancel out, it becomes a 1. So that's another way to look at it, okay? All right, here's another one. So we're going to clean up the top first here. So they're being multiplied together. So that means we are allowed to add the exponents. Okay, we'll just keep writing the bottom one along. And then what we're noticing here is that we end up with the same exponent at the top and at the bottom. Okay, and then you're going to subtract them, get to 0, which will get us to 1. All right, then from there, now we're moving to the negatives. Okay, so we don't see the 0 anymore, but we see the negative. Okay, so again, the rule is get it to a positive exponent. So let's draw 1 under here. So to get that to a positive, we're just going to flip it. There we go. Okay, so it becomes a positive. And then, again, like last day, I said you could just stop here. I want you to take one more step now. Now that you've kind of gotten comfortable with exponent laws, actually calculate this out. So again, take your calculator, 3 to the 4, 3 exponent button 4 equals. Okay, so just a reminder that exponent button is different on your phone, different on other scientific calculators. So just, again, find the one that works for you. And we get 81 for this. And you can just leave it like that. Okay. All right, keep going here. Here's another negative. We have to fix that before we can calculate it. And then we get a really, really big number. Okay, so you can just leave it like that, okay? All right, then we get to this different type here. See how it's -4, and then we have an exponent -2. So this is the problem here. We're allowed to have a -4 down here, but the exponent being a negative is an issue, okay? So we're going to do what we did before. So we need to fix that. So we're going to flip it. And then, so the question that gets asked is, okay, that 4, does that negative in front of the 4 also disappear? Okay, no, you have to carry it along, okay, in its bracket. The only thing that changes when you flip it like that is the sign of the exponent. So if it was -2 for the exponent, it becomes +2. But this -4 here, the negative on the 4, it has to just kind of carry along here, okay? All right, so again, if you have -4 squared, if we're not going to use a calculator here, it's the same as going -4 times -4, right? So that makes negative times negative makes positive. So 1/16 like that. Okay, here's one with the x. So even if we don't know it, we just got to fix the negative exponent. Okay, so when we flip it, it becomes x to the 5, or so now 1/x to the 5. All right, here's one where it's already at the bottom of a fraction, okay? So we have to fix this. So in order to do that, we just flip the fraction. Oops. So it becomes a +4. Positive 4. It's going to work in a sec, I think. Nope. flip it, there we go. So you get a positive 4, okay? And we can't calculate this out, so we'll just write it x to the 4 like that, okay? Because normally we don't write the bottom of it, of the 1 in the denominator, okay? So we can just write it like that. Okay, keep going along here. So L, so here I'm looking at this. I see a negative exponent, so I'm like, okay, I got to fix that. So the order that you fix these, it can vary. So I also see that I can multiply these, so that's allowed as well. So maybe that's what we'll show you, because right away you could fix it, but then you're going to get a bunch of fractions and it's going to get a little confusing. So for now, let's just use our multiplication law from the other day. So when you have the same base of 4, you're allowed to add the exponents. So we're going to write 4 once, and we're going to add the exponents. So the exponents are positive 3, and add it to negative 5, okay? So again, here your integer, here's an integer problem. So you have 3 shows up, negative 5 shows up. Who's going to win? The negatives. There's more of them. And how many more? There's 2 more. So negative 2. Okay, all right, so now that we got it to something simpler looking, now we can fix the negative. So we're going to flip it. Okay, and there it is. All right. Okay, move on to the next one here. All right, so again, like an I here, we had to respect that negative that was on the 4. We're going to do that here. We're going to leave it alone. But our goal is here to fix the negative 2 here, okay? This 5, it's positive, so we don't need to change it. So the only thing we need to change is this part here. So I want you to think of it as, you know, like this has a 1 underneath. So the only thing we're going to flip down is the y to the negative 2. So everything else stays. The negative 4 stays, the x to the 5 stays. But what flips down is the y squared. Okay, so now it becomes positive 2. And from there, there's nothing we can calculate, so that's it. That's what your answer should look like. Okay, and the last one of this example set here. All right, so we have a negative 3. I could multiply the negative 3 into the exponents. I'm going to decide here to flip it first. If you multiplied it in, it should work as well. It might just get a little messy, so that's why I'm going to just flip the fraction, get rid of that negative exponent. Oops. Okay, so if I flip it, the y goes to the top, x squared goes to the bottom. Okay. And you get a positive 3. And then from there, now you can multiply in. Okay, so remember this is an exponent 1 here. This one has an exponent 2. All right, so you're going to multiply that 3, exponent 3 in. So 1 times 3. And this exponent 2 times 3. And x to the 6. Okay, and then again, nothing that you can do further there, so just leave it like that. Okay, for this one, that one for n, if you wanted to try it the other way, so I can do that here. So what if you decided that you wanted to multiply that 3 in right away? Oops. Okay, so I don't think it likes that I'm drawing down here. Anyway, all right, so we have x squared over y. And then you have the negative 3. Okay, so that's the initial question. So what if you decided to multiply the negative 3 in? So this one is an exponent 1. This is what it would look like. Okay, so you're going to take the x, you're going to go 2 times negative 3, and then you're going to take the y, and it'll be 1 times negative 3. And then you are going to multiply those exponents, negative 6, and then you have y equals negative 3. Okay, so we have an issue here. They both have a negative exponent, so we're going to flip them. Okay, so we're going to move the y up, x to the bottom. Okay, and then we ended up with the same answer as above, but we used a different method. Okay, so like I said, there's lots of different ways. As long as you're following the rules, you can do that. So even with L here, I'll just do that L. Okay, so this was N again. I'm going to do L here. We have 4 to the 3 times 4 to the negative 5. Okay, so there it is. So what you're going to do here is, so what I used here back in the other, when I did it the first time, I multiplied the exponents, so I added them. So if you wanted to flip it first, you can do that. So I'll use a different color here. So this one you can flip. So if you do that, the 4 to the 3 stays up here, but when you flip this one, the 4 to the negative 5, it'll go 4 to the positive 5 when you flip it down. Okay, and then from there, now you have this division law that you can use. So that means you're allowed to subtract the exponents. Okay, so then you get 4 to the negative 2, which then you have to flip 4 to the positive 2, and then you get what you had above as well, 1 over 16. Okay, so sorry, it's messy. So again, just because you know a lot of laws now that you can use them in different orders. It's okay, and you can still get to the same answer. Okay, so all right, let's finish off with these last ones here, and then can do some practice sheets, and then complete the checkpoint. Okay, so I'm just kind of throwing a little bit of everything that you've seen for the last few days. So again, you know this means multiply, so that means you write the base and you add the exponents. Okay, so that's the multiplication rule. But the new thing now is we just left it as 6 to the 5 before. I want you to actually go through and calculate it out, okay? So 6 to the 5, you end up with this value here. So that's what I want to see. I want to see the work that you're showing me that you understand exponent law, but then I want you to actually go through and calculate out the value. Okay, but that doesn't mean like go and take 7 to the 5, write this huge massive number, write 7 to the 2, write a big massive number. So here, why don't I just do that to show you how it can be actually annoying. So 7 to the 5 is, so you have to write out, so if you calculate the top, you're writing out all these digits here. Okay, and then you go to divide. 7 squared is 49, and then you're going to divide that, and then you get 200 or 343. Okay, so a lot of digits there, but if you can use exponent laws, it's a little less writing and it's potentially quicker. Okay, here, so let's just erase this out and start again. Okay, so I'm going to use exponent laws here instead of just calculating out the large numbers with my calculator. So here, when you're stacked up like this, so remember the answer was 343, so we're going to see if we get the same answer. So here, they're divided, so that means I can subtract the exponents. Okay, so when I do that, I get 7 to the 3, and now all you put into your calculator here is 7 to the 3. Okay, and then you ended up with 343, just like I did the first time when I calculated out all those big numbers and wrote out all those big numbers. Okay, so that's why exponent law is great, because it can make your calculations kind of more convenient and just simpler to write out. Okay, so that was multiplication, that was division, okay, that we've seen so far. So now we're going to look at C here. Sorry, just having issues with the pen here again. All right, so this is what we did last day. If you have two exponents up in the air, it's a power of a power rule. So you're going to go and multiply those exponents together. Okay, so then you get 3 to the 12. But again, now you are calculating that out. Okay, so you get 531,441. Okay. All right, so from here, let's move to the next one. Again, I want you to just try to use exponent laws here. I know we can all use a calculator and calculate out these big numbers, but try to use exponent laws here. So here you guys are looking at an exponent outside of this bracket, so know that you can multiply this exponent into the other exponent. So 1 to the 1 times 2, and then we have 3, exponent 3 times 2, like that. Okay, so then 1 to the 2, 2 to the 6. So for now, we're just calculating that out and get 1 to the 64, and you can just leave it like that. Okay, so let's move on to the last two here, and then we're done. Okay, so we're seeing some negatives with the 2 in the brackets, and then we're seeing a division. So like we have a base of -2, but we have a division here, so that means we have to subtract the exponents. So again, don't touch the negative that's in front of the 2. Just leave it alone, and you're going to take the exponents though and subtract them. Okay, and when you do that, you end up getting +7. Okay, so, and again, so see how it's going to be -2, 7 of them in a row. So you know you have an odd number of negatives, so you know it's going to be a negative answer. And then 2 to the 7 is 128. Okay, and last one here. Okay, so if this exponent 2 is on the outside, it can multiply to the exponents on the inside. Okay, so then we get to there. Then we know we can divide these, so you subtract the exponents. Okay, and then we get -6, but to fix that, we're going to flip it. So right over here, 1 to the 4, 6, okay, and then 4 to the 6 is 4,096. Okay, and oops, that 6 doesn't look good. All right, so again, be able to throw all the exponent laws that you learned for the last few days. So if you haven't watched those videos, go back and watch them, and be able to use the new ones today where you have the 0 exponent and the negative exponent. All right, so go practice some of the worksheets and then try the checkpoint.